Hi and welcome to Geeks for Geeks. Today we would be doing the post contest analysis of GFG Weekly Coding Contest 113. So let's talk about the feedback of the contest. This contest was a very easy contest, I can say, because the problems were pretty balanced. The first problem being the easiest, the last problems being the hardest. Now, the only thing that I expected it to be that the last problem, okay, the last problem should had n equals to 10 to the power 5, because if the value of the last problem n, the maximum value of n is 10 to the power 4, then we can simply do an on square approach. But I think it should have been 10 to the power 5, so that we can just use our brain a little bit more and we can just implement a little bit better optimized solution. So the very first problem, let's talk about the very first problem. So let's talk about the hi Pawan, how are you? Hi Anshul, hi Ankit, hi V Athletes, hi Tej, hi Vasudev, hi Dhansami, hi Valentine, hi Vipul, hi Rohan. So this contest won't take much time, to be honest. Like the problems are pretty much easy to crack. Okay, so let's talk about the very first problem. Mhm. Yup. Mhm. He has the power to update the score by changing at most one digit. Find the maximum score. Okay. At most one digit. Okay. Hi Jyoti, Shakya. Okay, so I would pretty soon share the screen. So and it's there. So now see, we are told that, let me just see what we are told. Like we are given a number. Geek is participating and consist of digits 7 and 9. Okay, this is very easy to guess. Okay, so in the very first problem, we are given a number. Okay, we are given a number which is made up of just 7 or 9. Okay, so like we can have something a mix of 7 and 9. Yep, sorry. Okay, so either we can have 7, either we can have 7 7, either we can have 7 9, or either we can have something like 7 7 7 9, or we can have 7 7 99, and these all things. Okay, so now it is asked that you can change the value of at most one number. Okay, you can change the value of at most one number and you should have a maximum value. Okay, this is asked. Okay, so the recharge of my pen just got down, so I need to quickly recharge my pen itself. Okay, just a sec. I need to quickly recharge my pen. Okay, fair enough. Till then, let me just tell you what it is. We are given a number made up of 7 and 9. Okay, and we are told that we can change any value, okay, to a value like 7 can be changed to 9, 9 can be changed to 7. Okay, this is we are given. Now we need a maximum value out of it. Okay, we need a maximum value out of it. How to do that? It is very simple. Like I would just write it with my hands. Please bear it. Okay, so let's say we have a 9. Okay, so if we have 9, then if we change it to 7, the value would get lowered down. But we need a maximum value. So if we need a maximum value, our main focus should be to increase the value. So if we have something like 7779, then it is very easy to understand that we would change either of the 7 to 9, not 9 to 7, because छोटे values को बड़ा करूंगा, like 7 छोटा है and 9 is big, so छोटे values को बड़ा करूंगा तब उसकी value बढ़ेगी, but 9 को 7 पे लाऊंगा तो values तो कम होगी ना, so it is very evident that we need to change 7 to 9. But now the question is which 7 to change. This is very easy. Like if we change 7, like if there is, let's say, 7777, let's say, change, if we can change 1 7 to 9, which would be the most beneficial, please? So we already know that if we change up this 7, it won't be that beneficial. Okay, if we change up this 7, it won't be that, but if we change up this 7, it would be the most beneficial. Okay, so we can say that changing the leftmost 7 would be the most beneficial for us. Why? Because 7 jitna us side rahega, uski weightage utna zyada rahega. Okay, let's say we have like 111. If we increase, like let's say we have 111. Okay, अगर मैं किसी एक 1 को 9 बना सकता हूँ. Okay, if we can make either of the ones and convert it to 9. So converting this value to 9 would be the most beneficial one. So what we would do is we would do a for loop, and we would start from the left side, and the very first point where we find a 7, we would just change it to 9, and then we would return the value. Okay, this is very easy. So I won't talk much, because so it is just, when there are two observations to be done. The very first observation is that 9, we don't get, like we would the value would be lowered down if we change 9 to 7. So changing 7 to 9 is beneficial, but not 9 to 7. This is the very first thing. The very next thing is changing the values in the left side would be more beneficial than changing the values on the right hand side. These are the two things that we need to understand. Okay, and now let's move to the implementation. I think I'm good to go. Maximum number. If we have any. Okay. So now we would just convert it to a string. Okay. To implement it in a swift manner. Okay. And then what we would do is we would use a for loop for auto e. Okay. And e dash s. Okay, if the very first value, if e is equal to the character 7, if we reach a character 7, okay, what we need to do is we would need to make e is equals to character 9. Okay, and we have the power to make at most one digit, so we would break from this point, because if we have used one, that superpower that is given to us, and then we would return. Okay, this is to convert an integer to a string. This is to convert back from a string to an integer. So string to an integer, we would just do strs. What we are doing, string to integer. This is to convert string to an integer. So you can just write about stoy. Okay, in this. Screen is not clearly visible. Okay, I would share the tab, and that would make it solve the purpose. Maximum number, and this one should be solved now. Can you quickly confirm? This would solve the purpose. So, okay, I would just share it like this. So quickly tell me the point at which you are not able to understand, else I would move forward to the next problem. I don't think much discussion is necessary over here. Okay, fair enough. Move to the next question, sir. Sure. Thanks a lot, Valentine. Thanks a lot, Rajiv. Thanks a lot. Huh. Okay, like a very easy kind of solution. Okay, so now I would tell you next problem. I was able to solve it because I kind of solved the next problem. Okay, like next problem earlier. I have solved a problem like this earlier. So now my pen would be charged. Okay, I can write this much. Okay, so now in this problem, okay, we are told that we are given an array. We are given an array. It is very simple to understand. We are given an array and we need to tell if it is possible to convert it to a sorted array, okay, by performing what? By performing exactly two swaps. Exactly two swaps. So I would tell you what is the meaning of exactly two swaps. So we are given an array and we need to do exactly two swaps. That means even if one swap is there, even if one swap is needed, that won't be possible. Even if zero swap is needed, that is not possible. Even if just two swaps are needed, it is possible. Now, there are many things we can take the test case of. Okay, the most famous test case would be that 4 3 1 2, and we can have something like if we just keep up 1 here, if we just keep up 4 here, if we just keep up 3 here, if we just keep up 2 here, like we can just write all these things and then we can just find out all the number of test cases. Okay, the test cases would be such that, okay, if we kind of think, there are two ways people can think. The very first way is that if the number of values are more than 4, it is not possible. If the number of values which are disarranged are more than 4, it is not possible. Simple enough. If it is more than 4, it is not possible because more than 4 values would require more than 2 swaps, so it is not possible. The very first case. The very next case is A can crawl up to B, C, D. Okay. So what are the cases? A, B, A, C, A, D. Now B can crawl up to B, C, B, D. And then the last value can crawl up to B, like B and C, D. So if you observe, there are only six cases that you need to handle. Okay, these are the six cases. So if the number of disarranged values, like disarranged मतलब क्या? Disarranged मतलब वो सारे values जो अपने correct position पे है नहीं. Okay, we would compare it with the sorted and unsorted and we would observe that there are four values which are not in their sorted position. If there are just two values A and B, so what we can do is we can simply swap this up and we can swap back this if the array is sorted. If let's say this is sorted, if the array values are sorted, if we have something like, if let's say we have something like 1 2 3 4, if we have something like 1 2 3 4, we can make 1 go to 2 and then we can swap back it again. So the number of swaps were 2, and in 2 swaps I can have a sorted array in exactly 2 swaps. So I can say if the array is sorted, then the answer would be an yes to it. Okay, if the array is sorted. If the array is unsorted and there are 4 elements at max that are unsorted, we can have 6 conditions out of them. But to be honest, you don't need to think in this direction because you need to explicitly handle 6 cases. A easier solution to this in a nutshell would be, if you are going in this direction, it would be very much difficult for you to get the solution. Okay, but a very simple solution would be, I would tell you that, see, it is told in the question that it should require 2 swaps. It should require 2 swaps. So what I can do is I can have an array and I can have a sorted array. Okay. I would have the array and then I would another have an array, one more array, which is the sorted version of the previous array. Like this is, let's say, array A and this is sorted A. Okay, let's say this is sorted A. Suppose we have one, the example one would be 1, 2, 4, 3, and then we have 1, 2, 3, 4. This is the sorted version of this. Let's say we have this. The most simple one would be, first we would walk in this direction. See, we have 1 at its correct position. So there is no point in touching it. We have 2 in its correct position. There is no point in touching it. Next very thing is we have 4 here. And 4 is not at its correct position. So we would find the correct position of 4. 4 kahan lie honi chahiye? We can see that 4 should lie in the last position. 4 should lie in the last position. So we would take up this 3 and then swap it with the correct position. Okay. So we would find 4 and we would swap it with 3. That is 4 and this is 3. Sorry, we would try to find 3. This is the sorted version. No, sorry. We would try to find. So we know that this is the correct position of 3. यहाँ पे 3 होना चाहिए. We know that the intended value is 3, but the value that is residing here is 4. Okay, fair enough. So what we should do is we should find the position of 3, find the position of 4, and we can see that the position of 4 is the last one. So we just keep it here. So बहुत easy है, kind of. We would find the values which are not at its correct position. Okay, and then we would find the places where it intends to be. Like we know this value 10. Okay, ये 10 value 5th position पे रहनी चाहिए. Okay, so we would find the index where 10 should lie, and then we should take up that 10 and we should keep in that direction, keep in that place. Now there are 2 swaps that are needed. So that means finding the correct position is linear search. Finding the correct position is linear search, or you can simply use a binary search also, to be honest. Okay, because it is sorted array, you can simply use a binary search. But even if you do linear search, because there are exactly 2 swaps that are needed, so what you can simply do is you can find the correct position of 2 elements and then keep it at it. So the idea in a nutshell is, if exactly 2 swaps are required, then एक स्वैप कर दो करेक्ट पोजीशन पे जाके, दूसरा स्वैप कर दो करेक्ट पोजीशन पे जाके. C वैल्यू वुड बी इक्वल टू 2. अगर 2 से ज्यादा स्वैप लग रहे हैं देन इट इज नॉट पॉसिबल. अगर एकदम 2 स्वैप लग रहा है इट इज पॉसिबल. ओके, पहला पोजीशन मिसमैच पे जाओ. जब भी मुझे लगे कि भैया आपको तो यहाँ नहीं होना चाहिए था, तो आप उठ के अपने सही जगह पे जाओ. एक स्वैप हो गया. भैया आपको यहाँ नहीं होना चाहिए, आप उठ के सही अपने पोजीशन पे चले जाओ. 2 स्वैप हो गया. अगर तीसरा कोई एलिमेंट है जिसको फिर से उठ के अपने पोजीशन पे जाना चाहिए, then more than 2 swaps are required, and that is not possible. So if there are 2 elements that needs to go at its correct position and then swap it, it is okay, simple enough. So what we would do is we would make a copy of the array. So the idea is very simple. We would have we are given an array. We would create a copy of that array, and then we would sort this copy. Okay, and then we would start matching the corresponding values. What do you mean by corresponding values? इसका जीरोथ इंडेक्स इसका जीरोथ इंडेक्स से कंपेयर करेंगे, इसका फर्स्ट इंडेक्स इसके फर्स्ट इंडेक्स से कंपेयर करेंगे. दिस इज मेंट बाय कोरस्पॉन्डिंग वैल्यूज. And if we find that the values are not same at the corresponding indexes, we would say, bhaiya, what is your correct address? Okay, we would do a linear search for the correct address of that particular element, and we would see that, let's say it is on that x or something, so we would swap it, and then we would keep counting how many swaps are required. If the number of swaps at any point gets more than 2, we would stop at that position and say it is not possible. If exactly 2 swaps are required, it is possible. So the idea is, the question tells us now that can we sort this in exactly 2 swaps? So just do it as it is. Okay, keep a sorted array, keep the unsorted array. Okay, and then just perform 2 swaps and see if the array becomes sorted or not. The idea is this much simple. If the array becomes sorted after performing 2 swaps, then it is good enough. If it is not sorted, then it is not possible. Simple as it is. Okay, so I think I'm good to go with the solution. फिर से सोल्यूशन हिंदी में समझा जाए तो आई वुड क्विकली एक्सप्लेन यू द सोल्यूशन. मैं क्या करूंगा, क्वेश्चन ने पूछा, द आइडिया इन नटसेल इन जस्ट 2 minutes इज, क्वेश्चन ने पूछा कि 2 स्वैप में इसको सॉर्ट कर सकते हैं कि नहीं. तो मैंने क्या किया, मैंने उसको सिर्फ 2 ही स्वैप में सॉर्ट करने की कोशिश की. कैसे? एक सॉर्टेड रख लिया, एक एरे रख लिया. जो भी एलिमेंट, जैसे मैंने देखा कि इस पॉइंट पे ये एलिमेंट गलत जगह रखा हुआ है, तो मैंने उसको सही जगह पे जाके रख दिया. ओके, अगर 2 से ज्यादा एलिमेंट को सही जगह पे रखना पड़े, देन इट इज नॉट पॉसिबल. अगर 2 एलिमेंट्स को सही जगह पे रखने पे एरे सॉर्ट हो गया, देन इट इज पॉसिबल. Simple enough. And if the array is sorted, what we can do is we can just AB, BA, and AC. Like, it is very easy. Like I am sitting here and my girlfriend is sitting at this point. Okay, like me and my girlfriend is sitting there. Okay, let's say my girlfriend asks me that मुझे यहाँ पे बैठना है. So she sat here. Okay, and we swapped our position. Now, after swapping, she is telling, no, I feel more worse where I was sitting. So we swap back. And then we both are at our original places, and the number of swaps required was 2. So it can be just simply easy, like swap and swap back. Okay, that is why if the array is already sorted, then the answer would be possible. Okay. So now let's move back to this position. Inversion count करना, इतना कुछ करना, don't think about it. Okay, I like, you don't need to think in that direction. 2 swaps, it is asked that 2 swaps are needed. So just try to make it sorted array in this 2 swaps. So now I'm a very lazy person, N and A itself. Okay. So now there is one thing. Also, if you perform swap, okay, I would just do it. Okay, now it is told you cannot perform swap if you have only one element. So if the array is sorted, okay, one element array, like if it is just 5, then it is also sorted, but we can't. Something just got into my eyes and it is feeling irritation, and I'm feeling irritation. Okay, fair enough. So that is why if the number of elements are less than equal to 1, then it is not possible. So if n is less than equal to 1, then it is not possible. Okay, it is not possible. Now I would keep a copy of that array. Okay, we would make a copy of that array and then we would sort it. So we have a array and we have a sorted version of it. Okay, v dot begin comma v dot end itself. Okay, we have an array, we have a sorted version of it, and we have a count to keep a track how many swaps are already done. Okay, count to keep a track how many swaps are done. So I would just stop the screen and then I would share this one, 2 swaps like this, so that earlier people told me na, like they were not having a good view of this. Now they would have a good view of this. Okay. So someone Valentine is talking Boolean class int for int I is equals to 0. Okay. So now we would what we would do is we would start the iteration for int I is equals to 0, I is less than n to match the corresponding values. So now we would say sorted value is not equal to the given array value. Like we found a place where the corresponding values are not equal. Okay. So then we would find the correct position of that. Okay. So now we would see what is the correct position that is to be kept here. Okay. So the correct position that is to be kept here is vi where it is placed. Okay. So the correct position should be vi. Okay. So we have ai not equal to vi. So suppose we have 4 3 2 1. So the very first position 1 2 3 4. The very first position is 1. Okay, this is what? This is v of I. This is v of I. This is a of I. Let me just explain you. See, 1 and 4. Okay, 1 and 4. So we found the position where ai is not equal to vi. So we would try to find the correct position of ai, and then we should keep it here and we should swap it. Okay, so find the position of vi in ai. Okay, fine. So we have found that it is on the fourth index, and then we would just swap it. So find vi in ai. So what we can do is we can simply have a linear search. We can simply implement a linear search over here, and then we would say vector int v. So we are given an element v. So we are given a vector and we are given a key. Okay, and then we would say int n is equals to v dot size. We would implement a linear search over here, and then we would say for int I is equals to 0, I is less than n, and I plus plus. So we would say at any point if we get the element that we were searching for, we would return that I. So we would say return I. If we were not able to find the element, that won't happen because we know that the element would definitely exist. Okay, so what we would do is we would swap a of I with the position, okay, with the position of vi. So जो एलिमेंट वहां पे होना चाहिए था और जो एलिमेंट वहां पे है, वी वुड स्वैप द पोजीशंस ऑफ बोथ. सो होना क्या चाहिए था? v ऑफ i. सो वी पोजीशन ऑफ होना क्या चाहिए था? पोजीशन ऑफ होना क्या चाहिए था? सो a swap a of, we need to do the swapping in a only. Swap a of ls. Okay, like linear search of find v of i. होना क्या चाहिए था? v of i होना चाहिए था. उसका पोजीशन ढूंढ लिए. a of i जो पोजीशन गलत है उसका ढूंढ लिए, and we are finding it. Okay, after this we would increment the count. Now at this point what we would do is we would implement something like if c is less than 2. Agar if the number of swapping that we have done up till now is less than 2, then it is fine. But if the number of swaps we are doing currently is 3, then it is not possible. Okay, so if the number of swaps, if a swap is required, if there is a mismatch, that means a swap is required. So if we have some swappings left with us, then it is possible. Else we need to break at this point. C is equals to -1. We would initialize C is equals to -1. We would kind of keep a value. -1 would indicate that the sort it is not possible. The number of swaps required is more than 2, and we would break from that point. Okay, seems easy. Okay, found the first mismatch position. Mismatch hua. We found the correct position by doing swapping, and then we are increasing the value. C is equals to -1 indicate that a swap is not possible, because if the number of swap is less than 2, it is allowed, but if the number of swaps are 3 or 4, it is not allowed. So we are doing -1, that is to indicate that it is not possible, and then we are breaking from this point. It is very easy. So then we would say if c is equals to minus 1 or c is equals to 1, we would return 0 from that point. Okay, like if the value is minus 1 or the number of swaps required is 1, then also it is not possible. Okay, because we can't swap back. Else in all other condition it is possible. Yeah, just comparing and see how many errors am I making. Mhm. Yep, it is done. Okay, so the idea is very simple. Okay, if there is a mismatch, we would find its correct position and we would keep it. So that would be a swap. Okay, if the number of swaps are less, if the number of swaps are 2, it is possible. If it is more than, my solution works even if the numbers are not in the range of 1 to 1. This solution would also work if the if the number is not in the range 1 to 1. Okay, no. ओके, इजी ही प्रॉब्लम थी लेकिन अप्रोच सोच नहीं पाया. सो आई वुड जस्ट टेल यू अ स्मॉल थिंग. ओके, if I would just tell you, like, I use this. If the problem is like, if the difficulty level of that problem is easy, then I would kind of have a hint that इसमें 6 cases individually handle करना तो होगा नहीं. अगर ऐसा होता तो ये मीडियम प्रॉब्लम बन जाता. अगर इजी प्रॉब्लम है इसका मतलब मुझे कुछ सिंपल सा सोचना है. Okay, so I would just tell you a small example of what I do. Like when you start solving a lot of problems, then if you see a easy problem, you overcomplicate it. This is also a problem. Okay, so to not, like, a small hack would be what I use is, if the problem, it comes on the first or second or third or fourth, then I try to think in an easy manner. कुछ easy सोचो. अगर मेरे पास 6 cases आए, I am able to explain you that 6 cases ऐसे आएंगे. That means I also thought of it. I also thought that there are 6 cases. Okay, I would show you in the board also. Like, it is not that I don't overcomplicate. I'm not a true problem solving god or something. See, I was also thinking like ऐसा कुछ तो होगा. Okay, so I was also thinking that there might be 6 cases. Okay, but then I thought that this is an easy problem. This one, I shouldn't overcomplicate this easy problem. This easy problem should have an easy solution to it. So then I try to think that ऐसा कुछ करते हैं कि जो एलिमेंट गलत पोजीशन पे, उसको जाके सही पोजीशन पे रख देते हैं, वो एक स्वैप हो जाएगा. अगर रखने के बाद 2 स्वैप नीडेड है, then it is fine, else it is not fine. Okay, so I don't know how you implemented quick sort can work here. I don't know how you are implementing quick sort. So this is what approach I have used, and I kind of gave the contest in the manner that I would have given. Okay. Yes, you can kind of follow this approach. If the problem is an easy problem, try to think it in an easy manner. Okay, that just doesn't mean that you should think overcomplicate a hard problem. Okay. So now let's move to the next problem. Next problem काफी interesting है. Now let's see the. So am I clear with the problem? Can you give me a quick one? इस point पे आके एक बार one मांग लेता हूँ. If you are clear up till this point also only or not. Just give me a quick one if I'm clear with the second solution. Can we use quicksort? Didn't use quicksort, to be honest, so I didn't really know, but I think quicksort should work. Okay, but इतना easy solution है हमारे पास. I know the solution is a little bit long, but it is very intuitive, to be honest. Okay, like if a number is not in its correct position, try keep it in its correct position. Correct position can be found out by using simply a linear search in the sorted array, or you can simply use a binary search also. That is also done. Best approach to solve the second problem would be to use binary search instead of linear search. If we just replace the linear search in my code to binary search, that would be the kind of best solution, because at max you would be doing 2 binary search. So it is big of n multiplied by 2 into log base 2n. and that would be kind of very good. Okay, no, quick sort is not good because quick sort is also good enough because both like quick sort would also take n log n, and I'm also sorting the array, so that is also n log n. So both the approach is good and kind of very simpler. Okay, try to take the intuitive one. Okay, as of now, if you're starting off, don't try to get the best solution. Okay, you won't like you if you don't understand it fully. Try to take a solution which you are able to understand and which you can think that if I get a contest, I can think of this solution. मैं ऐसा solution सोच पाऊंगा in the contest. Okay, that's why I try to keep it raw. I thought of linear search in the contest, so I took up linear search. Quick sort. I'm confident that it should work. Okay, but I can't claim that it would work. Okay, because I didn't do it. So now comes the position of the last element. ये last element अच्छा है, ये last question अच्छा है. चलो देखते हैं. But by the way, after a long time, I had my beard cut off, like on my own. No one told me. Okay, ये वाला थोड़ा अच्छा है and it is kind of easy to get. Okay, अब इसकी जरूरत नहीं है चार्जर की क्योंकि ये लास्ट क्वेश्चन है. ओके, आराम से करते चलो. तो देखो भैया, it is told we need to find the pair of x and y. Okay, look, let's say no, we are given a value x, we are given a value x and y. Okay, we need to find I and j, pairs of I and j. What is the pair I and j? A of I multiplied by a of j. It should lie in the range of x and less than equal to y. It might be a scenario that I am interpreting the question in a wrong manner. Let me just see the question itself. Am I given this relation? Okay, so we are told that we need to find AI multiplied by AJ, okay, and it should be in the position x and y. It should lie inside the range x and y, and it is also told I should be less than equal to I should be less than j. Okay, so now AI multiplied by AJ. If I is less than j, this is same as x less than equal to, so I would just give you a hint also. So multiplication is associative, so a multiplied by b is equals to b multiplied by a. It is associative, so I can say a, so it is same like a of j multiplied by a of I, and then it is less than equal to y. This is both are same, both are equal. Okay, both would be equal. Okay, a को इस तरफ रखो या उस तरफ रखो. This is the first observation, that multiplication is associative, so I can just change the ordering of this. Okay, so now the very next thing that we need to do is, what we can do is, see, I have a range x and y. Let's say this range is 30 and this range is 50. Okay, this range is 30 and 50. So now what I can do is, I would have, like, this solution is a little bit over complication to the time constraint, but the easy solution won't teach us anything. Okay, so I would teach you a good solution, to be honest. Okay, so now let's say we have two 3, 5, 8, 10, 2, 3, 5, 8, 10, 12. Let's say. Mm, this is good enough. And then 14. No, let's take the example only. That would make more sense. Let's see the example and let me write it down. Yep, 3 na. Okay. So x is 8 and this is 13 and the values are 3. So the values are, I would just write it in the sorted banner. 2, 3, 5, 5 and 6. 2, 3, 5, 5, 6. Good enough. Now let me just share the screen again. So see, x and y is 8 and 13 and the value is like this. Okay, so I just sorted the array. Okay, why did I sort the array? Because the indexing doesn't matter to us, because multiplication is associative. So if the indexing does not make a difference, then I would simply sort it. Why I would sort it, I would tell you the reason also. Okay, so I found out that array is associative, so indexing does not matter, so I can simply sort it. So what I can do is I would take up this 2. Okay, so let's say this value is a of I. So I have a of I multiplied by a of j. So if I make a of I as 2, then it would be nothing but, let's say, 2 multiplied by, let's take this value as t, 2 into t. So 2 into which values would lie in this range between x and y. So what I can do is, see this very carefully. I would do 8 multiplied by 2. It gives us 4. So that just give me 8. Okay, I would have 8. Okay, I would have, so I know that 2, 8, this is x. So 8 divided by 2, it is equals to 4. Okay, then we have 13. 13 divided by 4 is equals to 4 3s are 12. That is, sorry, 13 divided by 2, that is 6. Okay, so we know if t is from the value 4 to 6, 4 to 6, then it is feasible. अगर 2 multiplied by 4 to 6 में से कुछ value होगा, then it would be feasible. I would show you the reason also. So what I did was, I would just tell you here. Okay, so this was what I did here at this point was x divided by a of I and y divided by a of I, and I found out what can be the range of this. So if 2 is multiplied by 4, it would bring 8. If 2 is multiplied by 5, it would bring 10. If 2 is multiplied by 6, it would give 12. So if you observe, 8, 10, 12 are within the range of 18 to 13. Okay, so now if you are understanding this, then you have the solution. Trust me. Okay, okay. What I can do is, I took up just 2. And then I just tried to find out 2 can be clubbed with who all. So then I found out 2 can be clubbed with the values 4 to 6. How? I found out by this. Okay. So now let me just sum it up again. So what I did was, I simply sorted the array. So yeah. So I simply sorted the array. Okay. Then I did what? I moved forward and then, so yep, so I sorted the array over here. Then I took the first element. Then I thought that 2 can be clubbed with who all values. How can I find the pair of two? So if a of I multiplied by a of j should lie in the range x to y, I found out x by a of I and y by a of I. They would give me the range 4 and 6. So I know that the other value should lie in 4 and 6. How? 2 multiplied by 4, 8, 2 multiplied by 5, 10, 6, 2 multiplied by 6, 12. How many of you are able to understand till this point? Just tell me this. How many of you understand till this point? Just tell me this. Give me a quick one. अभी के लिए sorting भूल जाओ. अभी के लिए don't think that sorting is needed. We would come to the sorting part at this point. I didn't talk about the need of sorting. Okay. I just found out that indexing is not necessary. So if indexing is not necessary, then I can sort it. Into the future, can you quickly tell me? Let's see, the idea is that as of now, don't directly try to think of sorting. What I did was I had the first element and then I thought of this element can be clubbed with who all elements. Okay. Okay, this element can be clubbed. So this is x multiplied by y. So I would just explain you this. Let's say. Okay. So I would just explain you again because one person was not able to understand it in a very lucid manner. So I would just tell you, let's say this is x and this is y. Okay. And this range is, let's say 30 and this range is 50. Okay. So let's say I have a value. So this question is nothing, but let's say I have a value as 5. Okay. So now I ask you that I want the multiplication to lie between 30 to 50. I want the multiplication value. Like I want 5 multiplied by x should lie 5 multiplied by, sorry, this can't be x because I've used x. Let's say 5 multiplied by t should lie in the range x to y. I ask you this. Okay, let's say I ask you this. Okay, and I ask you what are all the values of t that I can have. The values of t I can have is nothing but 30 divided by 5 and 50 divided by 5. So 5 divided by 6, 5 divided by 10. So if I multiply 5 with 6, it would become 30. And so other value can lie from 6 to 10. So for 5 divided by 7 is equals to 35. 5 divided by 8 is equals to 40. 5 divided by 9 is equals to 45. 5 divided by 10 is equals to 50. This is very much easy to guess. Okay, this is, let's say, a value multiplied by t should lie in the range x to y. If someone asks me, and what are the different values of t I can have? So I would simply do x divided by t and y, sorry, x divided by that value a of I and y divided by the value that we can have. And the next value would lie in that range. Simple enough. Here also we did the same thing. Okay. So now we have 4. Now we want to see how many values lie in the range x to y. So we already have a range. So now the question is very much simple to understand. Now we already have a range. So now हमें पता चल गया. Now we have a range L to R. Now we have a range L to R. And we know that all the values which lie in the range L to R can make up a pair with A of I. All the values which lie in the array L to R can make up a pair with this. So I need to see all the values between L and R which are existing in the array. And at this point, I would sort the array. Here at this point, I would sort the array because I need to search values. Okay, searching a value becomes easy if the array is sorted. Why? Because array is sorted, then we can use binary search. That means log base 2n. If the array is unsorted, we need to use linear search. That is big O of n. So log base 2n is much better than big O of n. So whenever you have the need of searching an element, you should try to sort the array and then search the element. This is the need of sorting. This is why I thought that yes, in this intuitive approach, I need sorting at this point. That is why I told L multiplied by R is equals to R multiplied by L. Okay, I found it that the associativity associativity does exist, so I can simply sort it. Okay, so now the question is, what I would do is I would simply sort the values, and then I would do a lower bound. If you don't know what is lower bound, it is nothing but the first occurrence of it. Why I'm doing lower bound, let me explain you that also. Let's say let's say t lies from the range 4 to let's say t lies in the range 4 to 8. Let's say the t other value t lies in the range 5 to 8. Let's say the value of l is 5 and r is 8. So let's say the values are 5, 5, 8, 8. So we need to go at this index, and r is 8, so we need to go at this index. So to go at the first occurrence, we would use lower bound, and to go at the last occurrence of r, we would do upper bound minus 1. Upper bound minus 1 is to go at the last index. Please remember it. If we want the last occurrence, we would do upper bound minus 1. If we want the first occurrence, we would do upper bound. And we know that all the values from lower bound to upper bound minus 1 would contribute to our answer. So we would simply say, hello mami, stream এ আছি, করে কল করছি. Okay, so at this point we would say all the values that lie from lower bound to upper bound minus 1 would contribute to my answer. Okay, now let's see that in action here. So now let us see this in action. Okay, so now let's say we have 2. So 2 can be clubbed with 8 divided by 2, which is equals to the value of t can lie in the range 4, and 13 by 2, which is equal to 6. Okay, so I would do a lower bound of L. Lower bound of L would get me here. Upper bound of L, 6, would get me here. Upper bound minus 1. So I would give the indexing at this point also. 0, 1, 2, 3, and 4. And then let's have it. So lower bound of L would give me 2. Okay, lower bound would give me 2, and upper bound would give me 5. So index 5, so upper bound would give me index 5. Index 5 minus 1 is equals to 4. So 2 to 4, we know that all the values in the index range 2 to 4 can be the partner of 2. So what I would do is this is answer is initially 0. So I would add up this value 4 minus 2 plus 1. Okay, so this is 4 minus 2 plus 1, that is equals to 3. Okay, so we now have the first element. We have now thought of the first element. The answer is 3 at this point. Now let us see the next step. We have the very next step, 3. 3 can be clubbed with which all values? So 8 divided by 3, 8 by 3. Okay, 8 by 3. Okay, 8 by 3 would make it 3. Okay, and 13 by 3 would make it 4. So I should have all the values from 3 to 4. But if you observe, if I do a lower bound of 3, it would point me to index 1, and upper bound of 4 would point me to index 2. Okay, index 2. So 2 minus 1 is equals to 1. It would be equal to 1. Okay, but if you observe, we have the correct value. Yes, 3 can be clubbed with 3 and it lies in the range 9. 9 lies in the range x to y. But we are kind of using the same element again. But here we are told I should be less than j. That means both the element can't be same. At this point, I can say that we should do a binary search Just if we are considering I, so we should do a binary search in the range I plus 1 till the value of till the value of n. So we should do a binary search over the this range. Why? So that we don't include ourselves. This is the first reason. And then we don't count the same pair again. Okay, so we can simply say that while doing a lower bound or upper bound, we would simply go for I plus 1 to n minus 1. So this was the small thing that I wanted to tell you, and this is the point where I needed. So 3, I found it that I am including myself again. I don't want this because it is mentioned that I is less than j. I is less than j means what? I can't be equal to j. If I can't be equal to j, that means we need to take two values. We can't take the same value twice. So I should do a binary search after mine so that I don't include me. But yeah, if I don't want to include, so it just this is the example would be, if I don't want to be included in a party. Okay, let's say there are n number of people, and then and there are n number of people, and I am also in the party. Let's say I am in a party and I want to find the people who are in a party other than me. Okay, I want to count the number of people in the party excluding me. So now there are two options for me. Either I get out of the party room and then I start counting, either I get out of the party room and then I start counting, or I I count the number of people and subtract one. There are two things I can do. Okay. So the easiest way here I am doing is I'm getting out of the party and then I'm counting the number of people. This is what I am doing. Okay, I'm getting out of the party room and then I'm counting the people. That is why I am saying that do the binary search from I plus 1 till the value of n, but don't include me at this point. And then we can simply do r minus l plus 1 and we would simply add it. Am I clear with this approach? And then we would simply move forward. I is equals to j is there at this point. I don't know. I don't know, man. No, it is mentioned that I should be less than j. No, I would just show you the point. Okay, my screen is shared. No, I should be less than j. If it was mentioned that I is less than equal to j, then it was not there. I read the problem statement correctly because I solved it. Okay. Okay. Fair enough. Easy peasy. So now we would do simply, now I'm a very lazy person, would make it a. It is not allowed, Jashwant. Can you quickly confirm that it might be a scenario that is not being updated? So I would quickly update it again. So till this point, this was not there. Now if it comes, yes, it is still there. I is less than j. That means I is not equal to j. So I would just share the tab. Okay, someone is asking me something. Bhaiya, when I am solving the second problem with binary search, when I'm passing the array into, let's say you write this function where, so I apply अभी हम अनसॉर्टेड अरे पास कर रहे हैं तो उसमें पॉसिबल होगा बाइनरी सर्च अप्लाई करना. So no, it is not possible, but we are finding the correct position. So we are finding the correct position in the sorted array. So sorted array तो v वाला तो sorted array है ना. So we can, why not two pointers? Jashwant, you have agreed. Thanks a lot. Why not two pointers? Because I am a person who is good with binary search. So, and this solution kind of, I found out, thought it to be intuitive. Like if you see some people here also, if you see, uh, 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 now the question is very easy. This one. Okay. So kind of when I found out the range x2 l2r, then I just wanted to find out the elements which lie in this range. So I don't like 2 point thinking in direction of two pointers was kind of overkill for this. So I kind of thought of this. Rajiv Kumar, I kind of encountered your zero at this point. Into the future, and Rajiv Kumar, can you quickly confirm that this thing is clear to you or not? Yes, Rajiv Kumar gave me a one. We just simply know how many elements lie in this range and add it to the answer. Yes, absolutely. But in searching position will the array change? But we need only the count. So I think yes, we only need the count. So the elements, if they just uh, do haphazard thing or not, that won't matter. Okay, we just need the count. Okay, so I think you can simply watch the recording. How many of for so I just want to know, because I don't want to get into any hate. So can you, how many of you can quickly confirm that if most of the people are able to understand, I would move forward to the implementing the solution. Else I would explain this with another example. Okay. If I would find the size of the array, so I would say a dot size itself, and then I would sort the array because the indexing does not matter. A dot begin comma a dot end, and we would initialize the answer is equals to 0. Then we would say for int I is equals to 0, I is less than n, and I plus plus, and then we would find the value of L. L is equals to lower bound. So we need the first indexing, but we should start from the next index. The searching should start from the next index. So we would say va dot begin, a dot begin plus I plus 1. So we are just telling that start the searching after me. Okay, start the searching after me. Then at this point, I would say x, okay, x divided by a of I. So x divided by a of I, if you do this thing, it would give you the floor value. But let's say I, and this is to find the index, this would return an iterator. This function would return an iterator. So if we just subtract begin, this would return the index. So this is to return the index. So there is a small thing that I wanted you to convey. So yep, see carefully at this point. Okay, यहाँ पे थोड़ा तो need होगा. See, here it was x divided by a of I. Okay, so we need to find the seal value of it. So to find the seal value of that particular element, you can use seal operator also. Like you can simply use seal in C++. So I would seal and floor function in C++, but I don't rely in this seal and floor function much. So what I do is, the value was a of I. So value was x. So the value was x plus a of I minus 1. So I don't know if you understand this or not. If you don't understand this, just do it on a pen and paper. This is to get the seal value. This is to get the seal value, and then this side I would get the floor value. So I would say r is equals to, instead of lower bound it would be upper bound, that else everything would be same. So I would just change this to upper upper bound, a dot begin plus 1 plus I plus 1, and the next value would be the seal value, floor value. So floor value mein this is not required because we have the floor value by default, and this is done. At this point, yep, this is done, and we would have upper bound minus 1 to get the last occurrence, upper bound minus 1 to get the last occurrence, and then this is correct enough. So now we would add to the answer, and we would say if L is less than equal to R, this is just for a check. If L is less than equal to R, let's say R is pointing and L is, this won't happen, but still, if L is less than equal to R, answer plus is equals to R minus L plus 1 to it, and then we would have the answer. So this was the most, like, I found it to be the most intuitive answer, short and simple answer. Okay. In the member, no matching operators for int. Okay. A dot begin A dot begin comma A dot end. A dot end. Okay, and then we have the value. Yep, A dot end. So yep, we have the correct syntax now. This should work at this point. Yeah. Error. One cannot be used at the index. I did why did I use one here at this point? I don't know why I clicked one. No matching operators. So to just avoid this small two statement problem, so I would just tell you, I would just copy this, the same thing. Like I don't think much is the same thing. Okay, and then I would copy the same thing again. A of I dot lower bound, here it would be upper bound, upper upper bound, and this would be minus 1 to it, and this would be y, and this plus thing should go off, and this should work. Okay, I thought that still I'm getting errors. Okay, the same thing. Yep, it's done. So I would give you the solution at this point. So now tell me if I am not clear with the solution. Tell me the point where I'm not clear. I just like the solution should be clear, to be honest. Yep, sorry. Yeah, I thought that how would I do like in the VS Code, like that's why I still like I should think that GFG should implement in spite of me being a software engineer at Geeks for Geeks. I don't work like the practice team and auth team is different. I work in auth team, but I still think that the practice team should implement a bracket colorizer thing just like in VS Code, and that helps a lot, to be honest. It's clear now. I wasn't able to think it about it during the contest. Thank you so much. Chalo. Understood. Thank you. Two pointers won't work because some numbers are repeating. Yes, I do think so. But still, I think there might be any solution. Okay, so that's it for today. आज को जल्दी हो गया. Okay, like 15 minutes before. So if you have any concern or queries, you can quickly ask me. Else, I would drop off at this point. You can just give me a quick one, and then I can just end the stream. Anyone has any queries? So at this point I would open the chat. If you have anything to ask, you can ask at this point. By the way, my name is Siddharth Hazra. I'm currently an SB at Geeks. Besides that, I'm also a Canadian master at code forces. I forgot to introduce me in the stream. I now remember it. For last minute school needs, India's last minute. Most thank you so much, Valentine. By the way, these all solution might be the scenario that they are not the most optimized one or something, but this is what I thought of in the contest, and we are kind of not explaining a DSA problem. We are trying to solve a contest problem. This is how I would have solved the problem if I had gave the contest. This is this I just kind of vomited my thought process, that at which point I thought of this, at which point I made observation. This is how what I did. Thank you so much, Dreamer. Thank you so much, Rajiv Kumar Singh. And these all solutions are designed just by me, and it is not copied from any of the comments. Like I say that it is copied by the submission. This is copied, but kind of I thought that these solutions are very much intuitive and easy to understand. That is why I moved up this. Thank you so much. So this was it from my side. If you still have any concern or queries, make sure you ask them in the LinkedIn. If I get time out of my SD and my mentor work, I would make sure that I reply you. If you have any feedback to me, consider giving it in the YouTube comments so that the reach of this video could be increased and this work could be justified. That's it for today. Good night, everyone. Happy weekend. Take care.